All right, we're going to do some practice problems for exponent rules that we just covered in the lecture. So if you didn't watch the lecture, you should probably go back and do that before we do the practices. All right, question 1. 3 to the 4th times 3 to the 7th. This is the example where we have the same base being multiplied together. To do that, we just add the exponents. The shortcut is to add the exponents. So that will give us 3 to the 11th power. On question 2, same type of problem. Negative 2 to the 5th times negative 2 squared, the same base being multiplied. We just take that base and we add the exponents. So that gives us negative 2 to the 7th power. Make sure you keep those parentheses because that negative needs to stay in as part of the base. Number 3, we have a squared times a cubed times a. And remember, when there's no exponent, it's implied to be 1, so there is a 1 on there. The base is a. They're all being multiplied together, so we're going to add the exponents, and that gives us a to the 6th. On number 4, there are two different bases. All of these x bases can go under one exponent. When we add those exponents, 2 plus 8 plus 7, we get 17. And there's the y squared, and it has no other y's to multiply with, so it's still by itself. On number 5, it looks like we have 4 different bases. We have a, b, c, oh, and there's even a d over here. So you can rearrange these if you want and put the a's all together if it helps you. There's a to the 1 right here. There's an a to the 10 here. That's it. When we put those together, we add the exponents, we get a to the 11. There's a b cubed here, and there's a b to the 1 here. And when we put those together, we get b to the 4. There's a c to the 5 and a c squared. Put those together, you get c to the 7. And it looks like there's only the one d factor, so just d to the 7. So a11, b4, c7, d7. On number 6, there are two different bases. The 4 and the negative 6 are both bases. So we'll put the 4 squared and the 4 to the 6 together, and that gives us a base of 4 to the 8. Now, you don't need the parentheses on the 4 because there's no negative sign. So that's why I kind of just left it off. Then we have a couple of negative 6's here. We got a negative 6 cubed and a negative 6 that has no exponent, so it has the 1 on it. When we put them together, we get a base of negative 6. We add the exponents to get 4. There's number 7. Okay, we got a lot of bases here. The first thing I recognize is there are some coefficients. They're not the same base, so we can't just put them together and add exponents. So we're just going to multiply them. Bring them to the front, negative 6 and 4, multiply them together to get negative 24. Then we have x's. We've got x squared and x to the 6. Multiply them together by adding the exponents. Then we have y's. Y to the 4th and a y to the 1. Multiply them together by adding the exponents. So we get negative 24, x to the 8, y to the 5. On number 8, we had a question similar to this in the lesson with the minus sign inside. So what we have to recognize here is these are the same base, 5x squared minus 3y, 5x squared minus 3y. They're the same base. We are not going to bring the exponents in. Exponents cannot come in and distribute over minus signs, so we can't do that. But we're just recognize that these are the same base being multiplied together. So our base is 5x squared minus 3y. We're just going to add the exponents and make it 5x squared minus 3y to the 6th power. And that's as simple as we can make it. On number 9, this looks really weird to some students, but these are just Greek letters. This is just an example that you can really use any kind of letters or symbols as variables, and the exponent rules still apply the same way. So this first symbol is called theta. There are a couple of them here. There's one here and there's one here. We're going to use the rule of adding the exponents because these are being multiplied together. We'll have theta to the 8th. The second symbol, I believe, is called psi. Add the exponents, we get a 6. The third symbol is alpha, and it only has the 1, so it's the invisible 1 implied to be 1. You can write the 1 if you want, or you could leave it off. It doesn't matter. Most people in algebra don't write the 1, but it's okay if you do. It's not wrong. On number 10, we're going to start using a different rule. Remember, when we divide the same base, we subtract the exponents. So the base here is 7. We subtract the exponents, 8 minus 3. We get 7 to the 5th power. That's a minus, not a times. Here we have a couple of different bases. We've got a 3 and a negative 8. So we're going to have a 3. We're going to subtract 5 minus 3 to give us an exponent of 2. And a base of negative 8 with an exponent of 3 minus 1, which is 2. We could multiply this out. These are not big numbers. We could. Maybe we should do that. 3 squared is 3 times 3, which makes 9. And negative 8 squared is negative 8 times negative 8, which would be positive 64. And you guys can figure out over to the side what 9 times 64 is. Let's see. 9 times 4 is 36. 9 times 6 is 54. Plus 3 is 57, so this would be 576. This is a question that it's not out of line to go ahead and multiply everything out because it was just squares. You don't have to do this on every question. If it was an exponent of 6 here or something like that, I wouldn't have taken the time to do it. All right, on number 12, we have the same base being divided. So the base is still going to be a. To divide, you subtract the exponent. So 12 minus 4, that gives us a to the 8th. All right, on this page, they start to get a little more complicated. We got to remember our rules. This first question is definitely division. So we're going to start with the coefficients, 16 over 8. Okay, that divides out to make 2. With the b's, we're going to subtract the exponents. 10 minus 5 makes 5. With the c's, 9 minus 1 makes 8. And the d's will cancel because they're exactly the same. On number 14, there's a lot of simplifying that needs to go on here. So let's look at the coefficients first. Negative 2 over 4 is the same or reduces to make negative 1/2. I'm going to extend the fraction bar out because it looks like I'm not going to do this all in one step. These x's in the numerator are being multiplied. To multiply these x's, we add the exponents. So we're going to have an x. 7 plus 3 is 10. We still have this x on the bottom, which I'm going to leave for right now, x to the 4th. The y's in the denominator are being multiplied. So we add this as 3 plus 1, these exponents here. So we're going to have a y, 3 plus 1 is 4, but we also have this y to the 5th on the top. And that leaves us with just this one lonely z squared here that doesn't have any other z's to reduce with. Okay, we're not done yet because we still have x's and y's that need to be reduced here. And this is the subtraction rule. So we're going to go ahead and do that. we're going to keep our coefficient. So we have a negative 1/2. All right, x to the 10 over x to the 4. 10 minus 4 gives us 6. So that would be an x to the 6 on the top here. In the next section, I'm going to give you an easy way to know how the x to the 6 stays on the top. If you think about it, there are 10 x's up here. There are 4 x's down here. When we reduce them, there'll be 6 left over, and they will all be on the top because there was more up on the top to start with. The same kind of thing is going to happen with the y's. 5 on the top, 4 on the bottom. They'll reduce 4 of them off. There'll be 1 left over, and it will be on the top. And we have this lonely z squared left on the bottom. So negative 1 x to the 6 y over 2z squared. All right, on number 15, there's a couple different ways to do this, but you should be remembering your fraction rules here. Multiply top times top, bottom times bottom, and then we will reduce. So top times top up here is going to give us a cubed b4 times a fifth c3. We can write all that out. A cubed b4 times a fifth c cubed. And the bottom will give us c times b. Now we need to simplify. We've got 2 a bases here that are being multiplied. We add their exponents. That gives us a to the 8th. We still have a b to the 4 and a c cubed over cb. So this b to the 4th and this c cubed carried over, and this cb carried over. So all I did was multiply these two a's together and add their exponents for the 8. Now I need to reduce this b and this c here. So we need another fraction bar. The a is done. There are no other a's. B to the 4th over b to the 1, subtract, gives us b cubed. And those are taken care of now. C cubed over c to the 1 gives us c squared. And now those c's are taken care of. So I don't really need the bottom of this denominator, do I? I just have a to the 8th, b cubed, c squared. All right, number 16 is a different rule. Don't forget what this rule means. This means there are 4 groups of 3 2's. And so this was the rule where we have one base with exponents stacked up, and we can do the shortcut of multiplying the exponents. So that gives us 2 to the 12th. Same thing on number 17. One base with exponents stacked up. The rule is to multiply the exponents, and so that gives us x to the 30. On number 18, you're going to want to be careful because these exponents are stacked up, but remember, this square is only on this x. It's not on this 3. The 3 and the x are not stuck together. The square is only on the x. This cube needs to go on the 3, but it also needs to go on the x squared. So this is where it's beneficial to write your bases out individually and put this cube on them. So the cube is going on the 3. It's also going on the x squared. So then we simplify. 3 cubed is 3 times 3 times 3, which is 27. These exponents are stacked, so the shortcut is to multiply them. And 2 times 3 is 6. Okay, number 19. This is the same kind of thing that we just did. This square needs to go on all these bases, and there are 4 bases in here. Remember, the 4 and the x are not stuck together. The x is getting this 7, but the 4 is not. The square is going to go on the 4, and it's going to go on the x7, and it's going to go on the y to the 5th, and it's going to go on the z. That's a z to the 1, right? Because it has the invisible 1 on it. And then we just use our exponent rules. So this is 4 times 4, which makes 16. When they're stacked up, multiply them. So we have x to the 14, y to the 10, z squared. Number 20, same kind of thing. This 5 is going to go on all these bases. Again, the -2 and the a are not stuck. The a is getting the cube, but the 5 is going on the -2 and the a cubed. So write them out. -2 to the 5th, a cubed to the 5th, b1 to the 5th, c5 to the 5th. And then simplify. All right, -2 to the 5th is -2, 5 of them multiplied together makes -32. A cubed to the 5th, use the shortcut, multiply those exponents, you get a to the 15. Same thing with these b's. You're going to get b to the 5, 1 times 5. And you're going to get c to the 25. -32, a to the 15, b to the 5, c to the 25. All right, on 21, don't be freaked out because it looks like a fraction starting with. Like I said in the lesson, if you can simplify this fraction inside here first, it will make this square easier. But these are all different variables, so there's nothing to simplify here. So we're just going to put the square on everything. So we're going to start with a 5. It's going to get a square. The a squared is going to get a square. The b cubed is going to get a square, and all that's going to be over the c4 getting a square, and the d5, d to the 5th getting a square. And then we just need to simplify each base individually. 5 squared is 5 times 5. It's not 5 times 2, guys. 5 times 5 is 25. This is a rule where the exponents are stacked up, so you get a to the 4th. Multiply those exponents when they're stacked up like that. b to the 6, c to the 8, b to the 10. All right, down here at the bottom, 22 and 23 are the hardest ones. If you could do these, you'd be really, really set for the midterm and the final exam. So let's look at this. Again, we need to put this cube on everything in here, but in this example, there are a lot of things that can be simplified. For instance, 12 and 4 we reduce. So we're going to reduce those before we cube them. All these a's, we can use our exponent rules to put them all under the same base, and we will do that before we put the cube on. So let's look inside the parentheses here. 12 divided by 4 makes 3. These a's are being multiplied together. When the same base is multiplied, the exponents get added. So we're going to add 5 plus 2, and that makes 7. We still have an a6 on the bottom and a b. Okay, so that's the beginning of simplifying that. There's still the matter of these two a's right here, and we should simplify this, get it all under one base. So the 3 is not going away, but these a's are divided, so that the rule is to subtract the exponents. So subtract 7 minus 6, you get a to the 1, and that's going to be up here, a to the 1. We still have this b down here, and now we still have this cube right here. This is a lot more simple here than this was. So this is going to be easier to put this cube on. Okay? So always try to simplify in parentheses first if you can. Okay, the cube is going to go on the 3. So we're going to have 3 cubed. It's going to go on the a. So we're going to have a to the 1 cubed over b to the 1 cubed. Well, 3 cubed is 3 times 3 times 3, 27. The rule with these exponents is multiply them. So we're going to have a to the 3rd, b to the 3rd. 1 times 3 is 3. And that's your final answer there. Number 23 is similar, just a little bit more complicated. That's it. You can see these coefficients reduced. There's 4 different x's in here that we need to put them all together, and we're going to reduce these y's before we do anything with this square out here. So that's always the first step. -4 divided by 12 does not make 3. It's a fraction because the top is smaller. So we're just going to reduce it. They're both divisible by 4. So we get negative 1/3. We could put these two x's together. It's multiply, so just add those exponents. You get x to the 8. We still have a y to the 4th up here. We can put these two x's together. This is multiply, so just add the exponents. We get x to the 6th, and we still have a y down there. All right. Not quite done with this yet. Not ready to put this square on yet because we still have two x's and two y's that we need to put together. So we'll simplify this again one more time. So we have negative 1/3. That's not going anywhere. Okay. These x's, this is divide. So reduce. 8 minus 6 is 2. So this is going to be x squared, and they're going to be on the top because that's where more of them started out with. Y to the 4th over y1. This is a y1 makes y cubed, and they're going to be on the top also because there were more of them there to start with. So the only thing we really have in the denominator of this fraction is the 3. All right, so now everything needs to get squared. For convenience, I'm going to move this negative in front of this 1. It just makes sense to put it there. You could put it in front of the 3. It doesn't really matter, but I just like putting it in the numerator. So everything's going to get squared. So we're going to have a negative 1 squared, an x squared squared, and a y cubed squared, just by putting this square on all three of these bases. Then in the denominator, we're going to put the square on the 3. Okay. So negative 1 squared. Negative 1 times negative 1 makes positive 1. X squared squared, this is a multiply when the exponents are stacked up, so we get x to the 4th. Same thing here. Y to the 6th. 3 squared makes 9. Now, you don't really need this 1 here anymore. We don't usually write it. It's not incorrect if you do want to write it, but in algebra we don't usually write a coefficient of 1, so I'm just going to write this as x to the 4th, y to the 6th over 9.